Good morning, my YouTube viewers. It is Crystal here, and what I want to talk about today is autoencoders. And basically, what autoencoders do is they're used basically to get noise out of an image. Okay, you can use autoencoders for other things, like you can use an autoencoder on tabular data. But ideally, you use an autoencoder to get noise out of an image. And so what I'm going to do in this particular code review is I'm going to go over some code. I got the code from the Analytics VidHaya website, but basically what a lot of these websites do is they just use the same code over and over again, and they use the same data sets over and over again. And the data sets that they tend to use are the MNIST data set and the Fashion MNIST data set. So I decided to use a different data set that has a different shape to it. And then as a result of that, I had to modify the code. But I just wanted to say where I got the code from so you'll know. So I got the code from this website right here. But this website right here, what they do is they talk about MNIST. And MNIST is not the same as alpha digits. And then I'm using the binary alpha digits on TensorFlow as the data set that we're going to practice on. So what we'll do now is we will actually, I did this on wrote this program on a Jupyter notebook hosted by Google Colab. Google Colab is a great platform to use to write code. The only exception is that it does not have an undo function, not really. And as a result of that, you have to be very careful not to accidentally overwrite or delete code. If you do accidentally overwrite or delete code, you may be able to get it from the changes, saved changes. But that's not a guaranteed. So it's always best just to try not to do it. So the first thing we're going to do is we're going to import the libraries that we're going to need to create this autoencoder. So we're going to import Keras, and we're going to import TensorFlow. We're going to import TensorFlow datasets. We're going to import NumPy as NP, and we're going to import matplotlib.pyplot as PLT. That's what we're going to import. So then the next thing we're going to do is we're going to make our model. So model equals sequential, and in this model, it's got the encoder and the decoder in it. So basically, what's going to happen is you have the data, and then the first thing that you're going to do is you're going to encode it, and then the second thing you're going to do is you're going to decode it. So with the encoder part of the model, we're going to have a CNN convolutional 2D layer. The input shape is going to be 2016-1. So basically, what you need to know is the input shape of the shape of the images. And basically, with MNIST and Fashion MNIST, the shape of the images is 28 by 28. And so on this particular one, alpha digits, binary alpha digits, it's 20 by 16 by 1, 20 by 16. And so I had a lot of difficulty getting it to work because I had to figure out what the shape was, and then I had to make sure that the shape was the same. And then we're going to max pooling 2D, another convolutional 2D layer, and then another max pooling 2D layer. And then now what we're going to do is we're going to decode it, another convolutional 2D layer, a UP sampling 2D layer, convolutional 2D layer, a UP sampling 2D layer and another convolutional 2D layer, which is activation is sigmoid, padding is the same, and then we're going to compile it with optimizer is atom, and the loss is binary cross entropy. Now what we're going to do is we're going to get the data set. So train ds test ds equals tfds.load binary alpha digits, split equals train 80%. And it's hard to do it because and that's one of the problems with TensorFlow, because TensorFlow has gone through so many versions that you never know what you're going to be using. But the split is train 80% and then train 80%. That's what we had to split in this instance to get it to work. So it's always a good idea to know what version of TensorFlow you're on. I know I'm on version 2.12 at the moment with Google Colab. And then after we load our data set from TensorFlow, we're going to convert it to X-train and Y-train, and we're going to do it with NumPy arrays and a lambda function. So X-train equals np.array list train ds.map lambda I is image, and then you do your Y train is the label, and then you do X test Y test. And now what we're going to do is we're going to normalize the data, and what's going to happen is a lot of times you're going to see, especially if it's with MNIST and fashion MNIST, they're just going to say, well, divide it by 2.5. And the reason why that is because MNIST and fashion MNIST is 28 by 28, and that gives it 2.5. But I think the better way to do it is to normalize the data is X-train equals X-train minus X-train min over X-train max over X-train min, because the alpha digits, binary alpha digits, is not 784. And because it's not 784, if you try to divide it by 2.5, it's not going to work. And I know that because I tried it. So the best thing to do is to actually do the normalization formula instead of dividing it by 2.5. And then you do X print shape. And then when we did the shape, that's how we found out we had a shape of 20 by 16. So now we're going to reshape the data. X-train equals np.reshape X-train len X-train 20, 16, 1. And then you do the same thing with X-test, and that's going to reshape the data in accordance with this binary alpha digits. And then we're going to train the model. Model.fit equals X-train, epochs equals 15, batch size equals 128, validation data equals X-test. So that's the difference between, if you'll notice the difference between an autoencoder and a regular model that you make predictions on is with the autoencoder it says X-train, and with the regular model that you make predictions on, it's going to be X-train, Y-train, and X-test, Y-test. So now we're going to predict on the model, pred equals model predict X-test, and then we're going to plot the figures onto a screen, and then we're going to display. We're only going to print like 5 figures, but we're going to display the original figures and then the reconstructed figures. So these are you can see that your original figures look much better than the reconstructed figures. But the idea, that's why I think they say to use this to to denoise an image, because the original figures are always going to look better than the reconstructed figures. But you can see that the reconstructed figures are very similar to the original figures. So now what we're going to do is we're going to denoise. We're going to create a denoising autoencoder, and so we're going to use the same data that we used in the previous cell. So noise factor equals 0.7. So we're going to put some noise into these simples. X train noisy equals X train plus noise factor times NP random.normal. Log equals 0.0. Scale equals 1. Size equals X train shape. And then we're going to, this X test noisy is going to be the same as well. And then X train noisy equals NP clip, X train noisy 0, 1. And the same with X test. And then you can see we're going to print a figure of what the noisy images look like. And you can see that you can barely make them out because they've got so much noise in them. And now we're going to put the noisy images through the autoencoder. The first thing we're going to do is we're going to encode it, and then after we've encoded it, we're going to decode it and then train it for 15 epochs. And then after we've encoded it and decoded it, now we're going to make predictions on it. And after we've made predictions on it, you can see that what the decoded noisy signals look like, because it took the noise out of the signals, and it looks very similar to the previous images. So that's basically what an autoencoder is for, is to remove noise from the image. And you can see in this particular example, the images have had the noise removed from them. So I'm going to go ahead and conclude this video because we talked about what we wanted to talk about, autoencoders. I don't use autoencoders a lot because I don't work a lot with images, but as I begin to work with images, I'm sure that I will use autoencoders a lot more. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more videos for you in the future.